Okay, so my first meetup, starting with the talk right away. So in this talk is going to be about how to run more jobs with less work. Sounds great, and it is actually quite simple. So I hope I'm going to catch up all the time we already are behind today. First about me, I'm Grewe. My job title is DevOps engineer, but I'm actually more of 99% ops and 1% dev, because I've been doing system administrator jobs since 1999, and I joined Flixbus last year and work in the platform or Kubernetes team. So that's why there's not that much development and rather more infrastructure cloud stuff going on. I hate Jenkins. I'm sorry, I'm biased. I love GitLab and I can't PowerPoint, but you'll find out about that in the next couple of slides. So I wanted to talk to you about where we started, what happened, what we tried to improve, and what we're trying to do as the next steps based on the continuous learning. So when I joined the company, there were multiple Jenkins instances, and those were maintained by, I still haven't found out who actually. So, and I never liked Jenkins because it's a plugin hell, and upgrades with Debian packages are pain in nowhere. The user management, because we had multiple instances, was always a problem to keep those in sync, and I think I have access to at least one instance we run in this company, but I didn't even care anymore because we had GitLab. So we also had GitLab runners, but unfortunately those were maintained by the teams, supposedly. Most of them not actually. So that meant that people used CI scripts for GitLab that had features in them that weren't supposed to, or that weren't running with their version of the runners, because those were completely outdated. That was one problem, and the other problem was that you pick the runner of your job by using tags. And so people ran loads of runners on different systems in different environments, all with the same tags. So some of them were able to build Docker images and access AWS resources, and some of them not at all, and some were reserved for Android, and everybody was complaining if we ran on there. So it was all over the place. So a bit of that was our fault, because when we, especially when I joined, and I was pushing very much for using GitLab CI. So whenever somebody came with something like, we need to build a CI pipeline, like, have you made GitLab CI? So we had the policy, if you bring up a new project, please try to get it to work on GitLab CI first, and if that fails, use Jenkins, because yeah, some stuff Jenkins does better, different. So we try to get as many people as possible on the GitLab pipelines, because that worked awesome. So because people were sharing their CI scripts of what they did, and the other team CI scripts were just there in the repository. So there was a lot of exchange and just searching on GitLab on what are other people doing there. And we also added the Kubernetes token injector. That is kind of what is a service that runs, and if you add a GitLab user to your project, then your project will get secret variables with GitLab Kubernetes tokens to deploy there during the CI job. So that was like an integration. The developers don't need to care about authentication against the Kubernetes clusters. They could just say, like, add the user, deploy. So that was also a big plus for them. So that resulted in, as Churchill would be proud, the very, very rapid rise of GitLab jobs, and Jenkins still being used for some stuff, because, and those are absolutely true numbers, definitely. Yeah, so people switched to GitLab a lot. And then we had those issues with the runners not maintained, or, well, kind of running in environments where people were trying to access stuff where they couldn't. So we thought, like, we need to do something to align all those runners. A bit of a background there, we have something we call Flixbus, which is actually, well, it's AWS. And teams get AWS accounts by, on the simplest way, just saying like adding their team name to a config file. That would be the simple way of telling it. And they have GitLab runners in their accounts to access their AWS resources, which we call team runners. And then there are the shared runners, the auto-scaling pool, which is going to be the bigger part of this talk. Because we wanted something that is cost efficient, scalable, and not a pet. So Flixbus, yeah, like I said, it's basically you add a team name to a config file, and then via CloudFormation templates they get an account, one for production, one for development, and the subnets in there, and NAT gateways and all that stuff, with a centralized access via Azure AD. So that already takes a bit of the authentication and user management away. As everything comes from templates, those team runners were already, we call them team runners, those runners in their accounts, were already always up to date because GitLab runner has a new version out. We just changed it in the template, deploy that, and all teams have the most current team runner running. That was pretty easy. And that's just what I talked about. Yeah. So the runner version always matches the GitLab version. Yeah, if we update that manually. So we at least the major version always is the current one. As we manage those, we as the platform team, the runners also have the credentials for our Docker registry already in there, so the teams don't need to ask for credentials, share them, put them in their CI jobs. It's on the runners. And they can just attach IAM policies to the runners as they see fit. For example, access my S3 buckets or SQS, whatever they want. So we provide just the runner, and they can tag that stuff on there. Those runners run 24/7, and because we have, I think, 30 teams at the moment, 30 accounts, 30 teams, 60 accounts, roughly something. It would be a bit expensive to have just a runner in every team account, like a large instance that costs hundreds of dollars per month, if they just run 1 or 2 deployment jobs per day. So those are T2 Nano instances, because in theory, those were only supposed to be used for accessing AWS resources in the respective accounts. But in practice, some teams have to run tests on there in the AWS account, and then the T2 Nano instance with, I think, 256 megabytes of RAM just doesn't get very far. So they didn't quite like that. So on the other hand, for the big stuff, we had this auto-scaling pool, and this is now the actually interesting part we wanted to get to the last 8 minutes. So this is a pool that is shared with all teams in all projects, so everybody who's in a company can run on there. There's no restriction, you just have to use the right tag. We're trying to keep that as close as possible to the GitLab version that is currently running. And we wanted it to scale as much as possible, so horizontally, so that as many jobs as needed can run without really bankrupting us. So there's a high limit of maximum runners that can run, but so far I don't think we hit that yet. And it was supposed to make at least 80% of the developers happy. We can't do that for 100% at the moment, because there are some teams like the Android team which needs an emulator device, and with just the regular EC2 instance on AWS, that is not as easily possible in Docker. So we're looking into a solution there, but most of the teams can run their jobs on there without problems. We also wanted those runners to be dumb, so there have been requests by teams saying like, okay, those runners run in your account, can you make them access everything in my account? And we're like, no, those are really just for building your stuff and maybe pushing to the registry or doing stuff that like accessing the internet, but we won't grant them any IAM policies to access other teams' resources, because everybody can run on those runners. So that would mean everybody could access everything in your account. So you really don't want that. And there have been requests of, oh, can you pre-install the AWS command line utility or something on there, and it's like, no, those run only Docker. We don't do shell runners on there, so we want them to be really throwaway. Either you can do it in Docker, or you should get it to do in Docker. Because they're for deploying to a monolith, that's done by a shell runner, but those we don't need on AWS. So we said like those are really throwaway machines, and we actually do it after I think 100 continuous jobs. They're killed anyway. So that's the general thing about the autoscaling pool. What we wanted, what we did. And the short version of this talk, of the last 10 minutes, would be just to Google this, because what we did was Google it, find the instructions from GitLab, and just implement them. And it is that easy. So I'm talking longer about this now than it actually takes to bring that up. And what it looks like in principle is you have a really small manager instance. The T2 Nano is what we're using, so that's cheap to run. And that spawns the actual job runners when there's a job, and kills them after 5 minutes when they're idle. And to have a quick job startup, there's always 2 of those bigger instances running. And then if more jobs in parallel get started, it adds more, but 2 are, well, up to our limit, are always running. And if you want to do that, you just need the EC2 instance like the T2 Nano. An IAM policy that allows this instance to bring up other instances and access an S3 bucket for the shared cache, which is probably the best feature on top of being able to run jobs on AWS. And maybe also an EBS volume where you mount onto that this manager instance to keep the state of the spawned runners if you want to update the manager. Because otherwise it may happen that you reprovision the manager and there were 20 instances running and the new manager starts blank and doesn't know about the 21, so they just keep on running. So using something that preserves the state is also a good idea, but for getting started, that's optional. So how this actually works is that the manager instance runs. It asks the GitLab API for jobs constantly, every 3 seconds I think or so. And when there's a job, it uses the EC2 API to bring up the instance where the job should run, generates an SSH key and SSL certificate for that to talk to that instance once it's booted, and then, so this is done via Docker machine, and then uses the Docker API once it has the connection to launch the container on there, just like it would do if it was running the containers on the local host. And if there's in the meantime any other jobs coming in, it just keeps on pushing out the jobs to any machines it knows about until there are no jobs left, and then it waits 5 minutes and starts killing those. So this does not use the AWS autoscaling group or anything. This is all done, or well, orchestrated by this manager instance. You don't need to do launch configurations and all that kind of stuff. It's really only this one instance with the right permissions is all you need. The bonus points for this are that if you set the schedules right, with the per second billing, you can bring the costs down a lot, because EC2 used to be built by per hour rate of usage for an instance. So even if you run it only for 2 minutes for a job, you will pay for the full hour. So with per second billing, if you set a very tight schedule, AWS is still expensive, but it's a lot cheaper than it used to be. You can create schedules that would allow your runners, like we do, to just in the morning at, let's say 8 in the morning, start the first 2 idle instances, wait for developers. Over the day, those 2 will always be there, plus additional ones that are required. And during the night, kill them all. And over the weekend, don't run any instances at all. And you can adjust that to whatever you want. So it's like your cron job style syntax. So you can have full flexibility for the timing there. Also saves a lot of money. The shared cache, that's this S3 bucket. This some people may be using also with just their regular runners that are not scaling. But this is really, really one of the nicest features, because it doesn't matter where you run them. as long as the runners have access to this S3 bucket, they can, well, cache. I mean, it's simple, but it can improve the build time for project if you're installing hundreds of megabytes of Node.js modules or Ruby gems or whatever. This quick from on AWS downlink from S3 bucket and uploading again is just a couple of seconds for gigabytes instead of building half an hour. So shared cache, even if you don't use autoscaling, use shared caching. A nice thing is also the silent takeover of jobs, because like I said in the beginning, we had dozens of runners running somewhere on some environments all over the data centers we were in. And we could just add any of those tags that other jobs from the teams were using, add those to our AWS runner, and then while both of those instances were running, we would run also some of the jobs that were intended for the instance running at Hetzner, for example, and we could shut down those later without having to tell everybody to please update your CI scripts, please run on our runners. We could just take their tags and they didn't even notice unless we did something wrong, which not that lot happened. But in the end, it worked out fine. And the GitLab runner now also provides metrics that you can scrape if you use Prometheus with Prometheus and put into Grafana dashboards, for example. So this is a mixture of what the runner provides, what GitLab provides, and what the node exporter provides. That we can see that how many runners we have running, how many are actually doing something like running jobs, how many are idle, how many over the last 24 hours were in use. So we're always hoping to get at some point over the 60% is it, I think. And we also need to update the query a bit. You can see that if there are no idle runners, if a new runner gets spawned, by average it takes about 64 seconds from the call of the manager to the job starts on there. And that number is way too low because I recently updated when I took the screenshot. I think we have in the last 5 months that we run this 60,000 roughly jobs. So in our GitLab runners overview, this is currently the runner number 2 with the second most amount of jobs run, compared to number 1, which has been running for I don't know how many years, and that only for 5 months. So that one is picking up a lot of jobs. There you see just graphs about how many runners at a given time were doing jobs, being scaled up, down, deleted, whatever. What the manager did to cause that. This helped a lot of finding the right size of the runner. This is the CPU usage of all cores for each runner, because we had some jobs which were starting going flatline at 100% and then at some point dying. So we had to dial in the size a bit, which is also really simple. I'll show you later on with the user data we use to just switch the runner sizes. Same for the memory usage, then the jobs per hour and how many idle runners, and that looks always way too high, but it isn't actually that high. They're just courtesy waiting for more jobs. So, some thoughts. We decided to disable the host key checking for SSH, because if you keep on throwing away your runners, the users, the developers, will have some way of telling their composer or whatever they're using to, yes, ignore the SSH host key. Here it is. So they're going to do it anyway. So then you can also do it right on the runner and save them that step. Or you could provide the actual host key for your GitLab instance, for example, or whatever Git repo you use, with the user data, which should also be easy. I guess that's going to be a bit more difficult if you do that with GitHub. I'm not sure how many host keys they have, but I bet the list is longer. Same for the credentials. If you use a Docker registry somewhere, if you provide the credentials with the runners, you save the hassle of handing A, the credentials to the users all the time, and B, you don't know where they end up in what config files, repositories, secret variables, and getting them rotated is a lot more difficult than if you just provide them on the runners and they're there and they don't have to worry about it. Yeah, like you saw in the graphs, monitor your runners, because that helps you to see, like, is the instance size right? Should I go higher, lower? I could have multiple pools with different instances per day, time, whatever, but disable alerts, because we kept them running, and then the weekend came, and then suddenly Prometheus started blaring that all the host exporters are down because, yeah, well, it was 7 in the evening and the instances were shut down, so we got host down alerts, but it was just the autoscaling. But still monitor them. And another big saving is probably to use spot instances. So the GitLab runner has support for setting a limit of how much are you willing to pay and what time block do you need for your runners. But also keep in mind that this could result in a lot of failed CI jobs, because depending on how long the CI jobs run, if it's a spot instance, it can be killed at any time. So if you can live with the failed jobs, but would prefer paying half, a quarter of what you're paying for your on-demand instances, then consider using those. And now the interesting part of how it's actually done, if you ever brought up an AWS instance, an EC2 instance, you know they can provide user data, which is like a text file that says on boot do a couple of things. And it is really that simple that you provided the cloud config that says write the config file for the GitLab runner, write another config file that includes the user data for the runners that get spawned, and you can put anything in there you want, like run the node exporter so you can monitor it, and write an SSH config that says ignore the host keys and here are my Docker credentials, and then at the end run the container with the GitLab instance, with the GitLab runner. So this is more a bit the logical overview. Ours would look like, let me show you. So this is the first file where I said like this is the config for the GitLab runner. This is the config, no matter where you run it, this is what GitLab runner configs look like, where we tell it to use S3 for the caching, use Docker machine with a schedule, or with those 2 schedules to keep 2 idle and 0 during the off-peak time. Then Docker machine options that tell the spawn machines a bit of like what instance size and whatnot. And to have those spawned runners include that user data. And that user data is just the other file we write there, where we say install a node exporter, write an SSH config that ignores the host key. Here's the registry token. And then at the end, run the container. So that is all the magic that is to doing this auto scaling. So I was a bit shocked to find out that it's really that easy. So where we're going is not that much, because we're really happy with this auto scaling setup. The one thing we have decided on is that we replace those small T2 Nano team runners in the Teams account with the same setup, just using a schedule that says by default no idle runners. And whenever a job for that thing comes in, it's going to take a minute maybe, but we'll not save money because it's still a T2 Nano instance running 24/7, but the teams will have whatever size they want for the time they need the instance, so everybody wins. And the other thing is thinking about multiple pools. So you saw the config file for the GitLab runner. You can add just multiple runners there, use a different runner tag and runner token, of course, and then have different type of instances run there. For example, if you have some instances that require 2 terabytes of RAM for your machine learning jobs or whatever, I don't know. You can have all that being done with just this T2 Nano instance that has multiple configs, and because it spawns them all whatever you want. So this is then the next step for the Android team, so they can run their emulators with GPU acceleration. Yep. So not much, just small increments. That's also the famous last word slide and questions, whatever you have. And of course, we're looking for new colleagues if that wasn't mentioned already. So if you're interested, we'll just leave those cards here. And if you want any of the source code, I mean config files rather, or Terraform plan or anything, how we bring those up, you can write me an email. And it is embarrassingly few lines of code really in Terraform and the Terraform config and the GitLab config. Yep, that's it. Question still. Was I too fast? Yes.
Yes. First of all, I believe it's 7 months now that AWS is building second base of some service.
Yeah. I think last year in October? No, but yeah, within the last year at some point it happened.
You don't have any more deployment power. A question.
Sure.
Do you have a specific caching mechanism system, or you are rely on?
So the GitLab runner, if you use just the GitLab runner somewhere on the machine, it will. If you tell it like cache something, it will start the job, then look if it in the cache path that itself knows about at some specific key, get a zip file, put it into a build folder, unpack it, run the job, and whatever you set cache, all those files, put them back into the zip and put that folder, that file back into the path on the local machine. So this shared cache thing you can replicate in your local environment outside of AWS by running something that is S3 compliant, like Minio, for example. And then the same thing happens, that at the start of the job, the GitLab runner will go to either S3 or whatever you have S3-like configured, download the file and put it back. And those S3 type caches are shared. So every runner that runs this particular job pipeline based on the project ID, you can define yourself what is the key of that, when we'll use that cache. So it's always going to be download or copy from wherever and put it back. So we don't do anything special. That's all the out of the box experience with the GitLab runner of just saying like use S3.
Yeah, no. We build the same, but we from scratch, and then
yeah, okay.
We have a lot of issue, and we combine not only S3 but also memcache for compilation that speed up a lot.
Okay.
More than the caching only. Caching is good for Gradle and other stuff.
Yeah, and node modules and that kind of thing. Yeah. The good tip is just make sure that you, when you set in your CI job, cache those files, setting the cache key. For example, setting the cache key to only the project ID will say every branch will use the same cache, which can fuck shit up.
You overwrite the cache as well.
And that, yeah. So pay a bit attention to the cache key, and then shared runners are a blessing.
I didn't check. It's possible that, for example, you have a piece of meat, and after that we merge in mainline to update the cache only when you merge.
I could look that up.
Okay, no.
Sorry.
It's fine.
Yeah.
The obvious question: have you looked at Fargate for like spinning up runners? Because that's in the end like you could just.
We haven't looked at Fargate yet, but so we run our Kubernetes clusters, or up to now we run them kinda manually, but we manage the control plane and everything. And we just started using EKS, so we're past the evaluation period and trying to onboard teams now. I'm not sure if we're ever gonna go full Fargate, but as soon as we switch to EKS, as that will finally do proper autoscaling compared to our clusters, we think about putting the runners onto that then, which is not sure who does better autoscaling, the Kubernetes, the horizontal autoscaler, or the GitLab runner by itself.
So that would be the Kubernetes executor then,
Mm-hmm.
instead of the. So one idea would be to have the Kubernetes executor Fargate, and then you have, in theory, indefinite.
Yeah.
infinite.
I mean, in theory, infinitely, we could also do with that up to until you hit the EC2 limits by AWS. Then you just write an email, and then suddenly it gets very expensive. Yeah. But the Kubernetes executor, I think, maybe slower. Unless you have a cluster where you, like, let's say you have 10 nodes running and they're doing some other workload, and then jobs get scheduled in there, and the Kubernetes executor just drops a pod. I guess it's
Is a pod.
yeah, it starts a pod in there. As long as there are resources, you're probably fine. But if you run a tight cluster that gets autoscaled just to the right workload size, when you start then, here are 10 CI jobs in parallel, then the cluster first needs to notice, I can't schedule all those pods. Let me bring in some nodes. And I think that's slower than what the Docker machine fire off per job an instance thing does.
Yes, I agree. That's where the Fargate stuff would come in. That you could connect like.
Because they're already running. True. Yeah.
There's a virtual kubelet which sits in front of the Fargate stuff, presented as a node, and which can take infinite pods.
Yeah. We haven't looked that deeply into Fargate, but if you have infinite resource already, then.
Tomorrow's a hackathon.
Another hackathon.
And I don't know the pricing. I'm betting that it's
a bit
ridiculous.
expensive,
Yeah, so trade-offs. Yeah. Anything else? Sure.
Sorry. Do you? Well, I understood that the team can decide the instance size. How many jobs?
And they can't at the moment, but they what our next steps thing. Yeah.
How many jobs you want to run in a single node? Do you have
We currently have it limited to one.
okay, so then you don't have any race condition across multiple jobs besides.
Well,
But do you have in mind to put any limitation on the? I understood that you run in Docker because
Mhm.
not install anything on the node. Do you think to force in some way the usage of CPU memory and so on in the node to avoid that?
Force in some way the.
Memory and CPU to avoid that the node go out of memory or is killed by itself by its test.
I'm not sure if I didn't understand or didn't.
Do you want to run the Docker with limit?
No. I think as the instances are currently what's it? M5X large, so 4 cores, 16 gigs, I think. As there's only one job running at any given time, if they hit the 16 gig limits, then there's no point in limiting it via Docker because that job's gonna.
They can tear down the node.
So
They can kill the node.
yeah, but that's gonna happen to the node anyway. So if we could limit it with Docker and say like, okay, now we can run 2 jobs on the same node, but then we again
But
we
well,
just scale.
What happened to us is time to time teams create something really huge, and then node is running out of memory, then they cannot kill SSH or something.
Yeah, but
then you have an empty node.
But
With
our
a
premise was we don't care about the nodes, no pets. So if the node dies, so be it. Because then usually they live less than 10 minutes. 5 minutes for the job, 5 minutes for the timeout. So the quicker they die, the cheaper they are. So we'd rather have the node go away than live as long as possible.
Who's killing the node?
The manager.
The manager.
So if there are no new jobs queued, he keeps on querying the GitLab API, and if GitLab API says nothing to do, then the manager will start, you go.
Well, what happened to us is sometimes the nodes stay in an empty state, that you have a second job that is allocated on that node and start to fail.
So if that was actually the case, we haven't hit that condition yet, I think. But considering that it's via Docker machine, always the manager talking to the Docker daemon on there, I guess if the manager can't talk to that instance, it will say, fuck it, kill it, next one. So.
Are you running no, because I see that you deploy the GitLab agent through then you run a job inside, Docker, not Docker in Docker, but sharing the socket to run another.
Yes, so the jobs run in a Docker container. The Docker container gets launched from the manager instance via Docker machine, via the Docker API there. But yeah, the job runs in a Docker container, same as if it runs somewhere else in Docker executor. And yes, we mount the Docker socket in there and say, go privileged and do whatever you want, because we're going to kill the instances anyway. So we're not really worried about anybody getting out of the CI job and doing something on the node, which is a blank Ubuntu 16.04 image. So yes, we had at first slight concerns about, but what if there are too many jobs running one after another? And so if the first instance, the first job does something bad and installs an advanced persistent threat on the runner, and then the next job that runs on there, because it got started within the 5 minutes, will be completely exploitable. But we're like, yeah, how likely is that?
Trust your users.
Yeah. So we have lowered the limit of after how many jobs and instances will get killed anyway. So everybody knows there is no security, but we kind of hope, like, if there's 10 runners running at the same time, an attacker would have also a bit of luck to hit the same instance he had with the previous job. So we have a relatively low limit of saying, like, kill the instance after X jobs that have been worked off on that instance, not only after 5 minutes. So they don't live long, even if there's a high amount of jobs going on. Sure.
What was the specific reason of moving away from Jenkins to GitLab CI?
People really liked it, that it's so easy to just add jobs on there. Ask the developers, and I was like, problems with Jenkins. Yeah, okay. So I think the main point is the ease of use of just dropping a GitLab CI YAML in your repo and then getting the instant feedback in GitLab integrated with Jira, Slack, whatever else you're using, that it's all just in one place. Jenkins can do that, probably, but don't ask me how many plugins you have to install and through what rings of fire you have to jump to make it all just work the way that GitLab does.
I can answer to this from a developer point of view. When we started to relate to GitLab CI, with this GitLab CI file, etc., Jenkins at that moment was not really supporting that way of configurations.
Oh, right, yeah, you had to configure in Jenkins a job, and then you were like, this is my Jenkins, and it can only run on there. Yeah. And then they added the Jenkins.
For Jenkins files? You moved to GitLab already before Jenkins files? Okay.
And from that period, of course, GitLab was for us like the perfect tool.
By the way, whose phone is that keeps on? Ah, okay. All right. Sorry. I hope I didn't hit stop there. No. Yep. Anybody? Again. The next one costs.
These are price and cost. Do you report to the team the cost of the things that they run?
No. We're planning to, of course. No, we just started. Actually, for this Q4, we have an OKR to provide more cost transparency to the teams and everything, and we have nice dashboards now, and we're still getting started in AWS. I would say I'm not even sure when we onboarded like half of the teams that are on there now, but it's still a bit of finding our own way. So at the moment we're not already trying to, no, that's expensive, don't do that. It's getting the people on there and then handing in a bill later on. No, but we try to do this, so we try to have everything tagged so we can really say this is from that account and this services ran, those are shared services like the Kubernetes clusters which run in our account, which we are paying for, not really, but So those would be per namespace built. For example, if we can say the namespace for team Death Star uses 50% of the CPU resources, 50% of the instances, so they pay 50% of our Kubernetes cluster. Kinda is how we hope we can do it at some point. And same would be for the CI runners, but not really.
After that, you will discover the problem how to integrate in the team budget. But
Yeah.
that's the second funny part.
We'll find somebody who care about that. I'll just run them. Okay, yeah.
Which subscription which plan are you using in GitLab?
The starter license, so the
The bronze.
enterprise, but the lowest level, yeah. Bronze is, I think it's
Yeah.
bronze, yeah. But everything that is
Yeah.
possible with CE.
How many jobs do you run a day, for example?
How many jobs?
You run in a day, you know, working.
Give me a second. So you see, the schedules work fine. At 7, the last jobs dropped, and since then, there weren't that many jobs, so we nailed that. Let's see, for the last... For the last 24 hours. If we say that on average there were, let's say 75 from 7 to 8 to 8, 12 hours, 75 per hour. Whatever he says, I trust him. Yeah, so an odd 1,000, I guess.
And
Yeah, I did the screenshot this morning, and then what did the screenshot say? 1,018. So now with the 2.7, it's 900 over the day. So
But today's what usually
And the average duration of the job is around like execution time.
I thought about monitoring that metric too. So you mean like how long a job runs?
Yeah.
But then again, we have so many different projects doing so many different jobs. That's apples and oranges. So I thought, like, nah, that's not. I only did. Where is it? A heat map. Okay, and that kind of doesn't look that good. Not that it looks ever good, but a little bit better is. So a heat map to see how long it takes from it hits the GitLab API to it gets started. So that metric is from how long it sits in a job queue of GitLab. This is not really runner related, more until GitLab says, oh, the job got started. And yeah, that's usually less than 10 seconds, but maybe we can just go a bit back to when there's actually something happening. So yeah, that was a bit more during the day. Yeah, so I guess 3 seconds until the job gets picked up is the average. That's the only timing metric I really have in there for the job related stuff, because everything that happens after that is, whoa. Anybody else? Okay, that's it.